nearly 4 decades. And he is continuing to raise his voice about our need to act on this problem. He's got many, many honors to his name. You can read all about him in the materials you've received, because I know you'd rather hear him than me. So please welcome Dr. Hansen.
Thanks very much. Let me see if I can operate this. Yeah, I want to talk about energy and climate from a global perspective. And if I point this way, it works. And we really need to look at this in even a broader context to understand the role that energy plays in the global situation. We have to consider. Am I doing that? We have to consider human health and global poverty. You know, the world has, about half of the world is now reasonably well off because of the benefits of fossil fuels. We were able to eliminate slavery and replace that with fossil fuels, and half of the world has become reasonably wealthy and reasonably healthy. Now, we will see some of the interactions of energy use with climate, and but the basic point is that if we're going to solve the global poverty problem, if we're going to solve the climate problem, we will need to stop runaway population growth. But in order to do that, you need to have abundant, affordable energy. The reason that half of the world became well off is that we had abundant, affordable energy. Unfortunately, it comes with some other consequences, and we realize that we're going to have to change the way we get that energy and the way we solve these problems. With regard to the climate, the situation has become very clear, even though the political systems have been unable to incorporate that information in and make appropriate policies. But the clear situation is that we have an emergency. We have a planetary crisis. But it's hard to get people to recognize it because it unfolds slowly, because of the enormous inertia of the world's ocean. We've only felt about half of the global warming that we will get due to the gases that are already in the atmosphere, just because it takes a long time for this ocean to warm up. And the danger is that we may push the system beyond tipping point, so young people inherit a system which is out of their control. And that the consequences will include some things that are irreversible. Someone just mentioned the fact that we're pushing species to extinction at a substantial rate, and that's partly because we're just taking over the planet. And we're putting stresses on different species in many different ways. But when you combine that with shifting climate zones, there's the danger that we could drive a quarter or a half of the species on the planet to commit them to extinction by the end of this century. And that's an irreversible impact which we really must avoid. Another thing that's irreversible on any timescale that anyone would care about is disintegration of the ice sheets and sea level rise, because it takes thousands of years to rebuild an ice sheet by snowfall piling up. And the danger here is that we're now warming the ocean, and the ocean is melting the ice shelves, the tongues of ice that come out from Antarctica and Greenland into the ocean. Just a few weeks ago, there was a paper published which showed in several different ways that the amount of melting of ice shelves around Antarctica is now approaching 1,000 cubic kilometers per year. You can actually measure from satellites the sea level rises as you get closer to Antarctica, because all this fresh water from the melting ice shelves is lighter than the salty ocean water, and so it is thicker. And that in turn is causing the sea ice around Antarctica to increase. But the danger is that if we allow this process to continue, we're going to guarantee that we will have multi-meter sea level rise at a level that will make all of our coastal cities dysfunctional, and the economic consequences would be unthinkable. So we really don't want to pass that tipping point, and we're probably getting very close to it. And there are also practical impacts of increasing climate extremes. And I'm not going to go into the climate in more detail, but this paper that we published several months ago, last December actually, I think makes clear that the idea that 2 degrees Celsius is a safe limit is wrong. That's actually a disaster scenario on the long run. We're going to have to phase out carbon emissions rapidly if we're going to stabilize climate. We've only burned a small fraction of the fossil fuels that are in the ground, the purple parts of the conventional oil, gas, and coal. And what's clear is that we've already burned the larger fraction of what we can afford to burn if we want to have any chance of stabilizing climate and avoiding disastrous consequences for young people and future generations. So that makes a very difficult problem, because if you look at where we're getting our energy, it's mostly from fossil fuels. The non-hydro renewables provide only about 3% of our energy. Nuclear power provides somewhat more than that, and that's carbon-free. But most of our energy is from fossil fuels, and that's true globally, not just in the United States. The non-hydro renewables are just about 3% of global energy. So we've got a huge problem. If you look at what's happening, we agreed to avoid dangerous human-made interference with climate in the Framework Convention on Climate Change, and the protocol that came out of that, the Kyoto Protocol in 1997, was so ineffectual that emissions actually accelerated after 1997. Instead of going up 1.5% per year, they've been going up 3% per year. Well, 3%, for about 3 decades, we've been working on renewables and subsidizing them as much as we can afford. But the total that we've got, 3% of total energy, is just the growth in 1 year of the actual emissions. So we're kidding ourselves if we think that we're solving the problem. We're not even stopping the growth. And so far, what we have done is very ineffectual. The crucial requirement is that we need to have inexhaustible carbon-free energy. We have to move off carbon-based fuels for our energy. But this has not sunk in to politicians' goals. They're allowing and encouraging us to go after every fossil fuel we can find, whether it's fracking to get gas or fracking to get oil in North Dakota or tar sands or drilling in the Arctic or deep ocean. There's something here doesn't connect. You can't say that you understand that there's a climate problem and still do exactly what makes it impossible to solve the problem. You know, and I found that it's not just the United States. Every country that I've gone to, except one, there's actually one country that has done something sensible. Here's the carbon intensity. What we actually are going to have to do with our energy is make the carbon intensity approach zero. The best that has been done is Sweden, which has about half of its energy from hydropower, so renewable energy. And the rest is from nuclear power. So its electricity is carbon-free. It still has about 25% the units for carbon intensity. But that's because of vehicles. But basically, they've solved the problem. And they did it by means of a large carbon price, a large carbon tax, and a government policy that they would build nuclear power and get carbon-free electricity. If you have carbon-free electricity, you're basically there, because you can make liquid fuels from electricity. They're right now more expensive than fossil fuels because governments subsidize and make fossil fuels so easy. But that, if everybody had carbon-free electricity, we would basically be home. Now, I want to show the first minute and a half of this little thing, if I can see how to do it. Let's see, I need to push. I want to play this. Is there someone? You have to push that thing. Is there somebody back there who knows how to make this work? No, it's not going. Oh, it's playing. Okay, so, but it's not, we don't have any sound. So I cannot play that, is this right? Is that right?
It doesn't look like it.
Okay, well, what this is, let me just tell you what this, it's a clip of a couple of minutes of this No Nukes concert in New York City in the 1970s after 3 Mile Island, in which it starts out with it shows a lady coming up to the concert, and she's saying, she has a coal-fired stove, and that's what we need is the fuels we have now, coal and oil. We don't need any nuclear power. And then there's someone singing a song that says, give me the warmth of a wood fire. So I want to then point out the other side of this wood fires and coal use. There was a very nice experiment that was done inadvertently in China when they the government had a policy to give free coal to everybody north of this wiggly line, this river going through the middle of China, for heating their homes in the winter. And this continued for several decades, and they have very good statistics on human health. And it turns out that coal reduced life expectancy by 5.5 years, and is killing well over 1 million people per year from the air pollution from the coal. And now, just recently, actually a year or more ago, there's this study on the global burden of disease from air pollution by the co-authors, including many of the leaders internationally in this research. And they found that the outdoor air pollution causes 3.7 million deaths per year. And this is mostly from fossil fuel burning. Furthermore, they show that indoor air pollution, which is from burning of coal and wood and field residues, and in some cases cow dung, causes 4.3 million deaths per year. So a total, not all of that is fossil fuels, but a substantial fraction of it is fossil fuels. And it's interesting that half of it is from heart disease and stroke, and half from pulmonary problems. And one thing, Pushkar Karicha and I wrote a paper recently pointing out how many lives were saved by the replacement of fossil fuel use with nuclear power. The number is particularly large in the case of replacing coal, but even in the case of gas, it's a substantial number of lives are saved by nuclear power. So it's somewhat distressing that our policy leaders have followed the easy path of taking advantage of the quasi-religion that's developed around the opposition to nuclear power. You know, the thing that led to this concert in New York, the 3 Mile Island accident, if you believe this linear no-threshold hypothesis for the effect of low-level radiation on human health, then 1 or 2 people may die over the next several decades from the radiation that Pennsylvania residents were exposed to because of 3 Mile Island. Out of 40,000 cancer deaths in Pennsylvania from other causes, although there's good reason to question this linear no-threshold theory. But in any case, in Bill Clinton's first State of the Union message, he announced that he's going to eliminate programs that are no longer needed, like research and development in nuclear power, despite the fact that the leading Department of Energy laboratory was ready to construct a reactor that could burn 99% of the energy in the nuclear fuel, compared to the 0.6% that we get from light water reactors, the 100 power plants we have now, and leave a much smaller waste pile and with a half-life of decades instead of tens of thousands of years. And in fact, that technology can burn nuclear waste and excess weapons material. So, and with our current technologies, we can avoid the kind of problems that occurred in Fukushima, for example. We can have technology that shuts down if there's an anomaly, like an earthquake. And it can continue to cool itself without external power, which was the problem that Fukushima had when they foolishly put their external power in the basement. And so we don't, and in fact, this newer technologies for nuclear power does not require, it's inexhaustible in the sense that we can sieve from the ocean all the nuclear fuel that we need, and it leaches from the ocean's floor fast enough to supply all the energy that we need on Earth. Not that we would want to use only nuclear energy. We should be allowing all clean, carbon-free energies, but we shouldn't eliminate one of the most potential just for political reasons. There's a nice book by Spencer Wert that helps explain how we can be so irrational about our fears about low-level nuclear radiation. This chart, which I borrowed from a presentation that I will mention on the following chart, summarizes the situation. Unfortunately, our current safety practices encourage keeping the dose of radiation as low as possible, regardless of whether it is negligible. And there's even a lot of evidence that suggests that low-level radiation is beneficial to health. That's undetermined as to whether it has a negligible effect, a very small effect, or a very small positive effect. Life developed on a planet that's enveloped in low-level radiation, and it's not surprising that biology learned to take advantage of that. And if we have people living in different parts of the planet under very different natural radiation amounts and with no negative effect noticeable in the regions of higher radiation. But if you're interested in this topic, I'd strongly recommend that you contact this Mohan Das, whose email address is given here, and those two prior charts were taken from his presentation. He's got a 100-chart presentation, which is really simple and clear, attempting to discuss the issues about radiation. I'm going a little too slow. I want to move on to say that, the fundamental problem is that fossil fuels appear to the user to be the cheapest energy. They're not cheapest, they just don't have to pay their cost to society. They're even subsidized, but they don't have to pay for the health effects, which are enormous. If your child gets asthma, you pay for it. If there's a climate-caused disaster, the victims pay or the taxpayers. So what we should do is have a carbon fee collected from the fossil fuel companies at the domestic source, the domestic mine or the port of entry. And that way, if that gradually rises over time, that will encourage renewable energies. It will also encourage energy efficiency, and it will encourage any no-carbon energy sources. But in order for this to be economically beneficial, as opposed to a tax is a drag on the economy, but if the money is given to the public, an equal amount to each legal resident, it actually stimulates the economy. There has been an economic study showing that if you went up $10 a ton each year, at the end of 10 years, the economy would have produced more than 2 million additional jobs and increased the GNP. And this is a conservative way to deal with the problem. And it stimulates the economy and would allow us to phase out fossil fuel use rapidly. At the end of 10 years, U.S. fossil fuel carbon emissions would go down 33% with this $10 a ton each year. And after 20 years, it would be down 52%. And renewable energies would increase energy efficiency and probably nuclear power. Certainly in countries like China and India, you would need to have nuclear power to replace all the coal use they're now using for electricity. And this is the only approach that can work internationally. You can't use a cap approach, a cap in trade or a cap of any sort. What would be the cap on India? They're using 1/20th of the carbon that we are per unit, per person. They're going to say we should get the same cap as the United States, and then the planet is shot, the climate is shot. But if we have this carbon fee, if even China and the U.S., or frankly, even if the U.S. decided to have a rising carbon fee and said we're going to put a border duty on products from nations that do not have an equivalent carbon fee or carbon tax, that would encourage other countries. It'd be a huge incentive for other countries to have an equivalent carbon fee so they can collect the money instead of having us collect it at our borders. And this would drive technologies. So the other point I would make is that the United States, what drives climate change is not the emissions today. China has become the biggest emitter, and they're now double our emissions. But what changes climate is the integrated emissions over time, because that carbon stays in the surface systems for millennia. It will mix, part of it will go into the ocean and into the soil, but it stays in the surface system for millennia. And so it's the integrated emissions, the cumulative emissions that count. The U.S. burned not only its share of the globe's carbon budget, but a large fraction of the share of China and India. So we really have a responsibility to help them. Because we've burned their part of the carbon budget, and we're all in the same boat together now. We've got to phase out fossil fuels. So we really should help China and India with technology. Instead, we've been withholding technology or making it very difficult for them. We still have some of the best expertise in the world, and we have the potential to have those technologies which would make our country again, a leader and economically a leader, and give our young people a future, an economic future, so they could look forward to a lifestyle as good as we had and maybe even better. But we can't do it if we're going to go down the road of becoming a petrostate. We may benefit for a decade or so from increased oil production, but on the long run, we've got to move in the direction of clean energies. And you can see where the real issue is now. It's the coal burning in China and the U.S. and India. Those are the big places. We really should be focusing on this. We're paying very little attention to it. It's an emergency, and yet our governments are not treating it like that. Thanks.